What you're about to see is an exercise in imagination. We've been studying an alien flying saucer. Here inside our top-secret hangar, we've examined the advanced technology that built it. Now we'll go inside to discover what optional extras are included on this model. An antimatter reactor, teletransporter, laser weapons. With the help of leading physicists, astronomers, and engineers, we'll learn about its power plant, its weaponry, and most importantly, its mission. And maybe in the process, we'll learn something about ourselves through alien engineering. This is an alien spacecraft that crashed in the desert some years ago. We recovered it. Now our goal is to discover how it works. We've been studying it for some time. Now we'll go on a remote video tour inside the craft. Our robotic camera is providing a remote video feed from the spacecraft, housed at Hangar 18. As you can see, this is something extraordinary. This is your first peek inside this alien vessel. Clearly, this is the main gallery, but it's not safe for humans to go inside yet. We believe this is the sick bay. This is the facility. Even aliens need one of those. Here are the control panels. This is where they operate the ship. We've hacked into their computer system, and we've learned a lot. Also, no joystick. We think they control it telekinetically. Below deck is an antimatter reactor. It's a complex piece of machinery, rather difficult to explain in lay terms. Camera off. So that's what's inside an alien ship. An antimatter reactor that can produce short bursts of intense energy to run powerful machinery, like wormhole generators and warp drives. And it runs on antimatter, the highest octane fuel in the universe.
If you had 1 ounce of antimatter and you could annihilate it with 1 ounce of ordinary matter, it would give you an amount of energy equivalent to 1 million tons of rocket fuel.
Antimatter sounds like science fiction, but it's real, and we humans are making it right here on Earth. Actually, below Earth, at the US government lab outside Chicago, 30 feet below ground, is a giant enclosed ring 4 miles in circumference. Here at Fermilab, the building blocks of the universe are being transformed into something fantastic.
Fermilab's mission is to do high-energy physics research. And high-energy physics research is trying to understand the forces of nature at the smallest distance scales. To see and investigate small distance scales, you have to have very high energy.
Why? Because the subatomic particles have to go fast. Very fast. Fermilab operates one of the world's highest energy particle accelerators, called the Tevatron. Here, scientists make particles of antimatter.
Back in 1928, Paul Dirac determined that we have matter, like protons, neutrons, electrons, and the things that they make up, and particles which have the same behavior, but their charge is opposite. And the term that was come up with was antimatter.
Protons have antimatter counterparts called antiprotons, identical in mass, but opposite in charge. Electrons have anti-electrons called positrons. Antiparticles can combine to create anti-elements such as anti-hydrogen. Theoretically, any element can have an anti-element counterpart.
In 1932, Carl Anderson was the first person to detect the existence of anti-electrons or positrons from cosmic rays. And then many years later, in 1955, Emilio Segre and his collaborators at the Lawrence Berkeley Laboratory in California created the first beam of antiprotons by using a beam of protons striking a copper target, and they detected for the first time antiprotons. Those were the first proofs of the existence of antimatter.
Quantum physicists predicted the existence of antimatter, but until 1955, they couldn't make any. It seems the universe is filled with matter and very little antimatter. So the most reliable way to get hold of antimatter is to make it. That's what Fermilab does.
We create antiprotons by taking energetic protons and slamming them into a metal target. It creates enough energy density in the target that you can create particles, and there's a certain probability that you will create antiprotons. It's a very small probability, but it is large enough that we can actually create numbers that we can count. For every 500,000 protons that we put on the target, we can collect one antiproton.
This all takes place in the giant accelerator rings underground. They need all that room to get the particles moving fast enough before they hit the target to make antiprotons. After the antiprotons have been produced and collected, the stream of antiparticles must be kept close to the center of the tube and prevented from coming into contact with the walls.
We actually magnetically levitate it. We have a ring of electromagnets with a stainless steel tube which has all of the air evacuated out of it. That's about 500 meters in circumference. And these antiprotons that are collected after these collisions with this target disk are put into this ring which we call the accumulator. And this tube is big enough and there's no air in it so that the particles can just sit there circulating.
They have to keep those antiparticles isolated, because if they come into contact with the particles in the wall, they will annihilate each other. So it would pose a big problem for beings like us, who are made of matter, if there was more antimatter in the universe.
It's a good thing that there's not equal amounts of matter and antimatter in the universe, because if I was to sit here in this chair and my antimatter counterpart came up and touched me on the shoulder, that would be the end of us and a good fraction of where we're sitting.
Matter and antimatter combine in a virtually perfect conversion of matter to energy. In other words, 100% of the matter and the antimatter become energy. Even in the best fusion reaction, perhaps 2% of matter becomes energy.
Antimatter is really the perfect form of energy storage because you get all of the energy out of the matter and the antimatter if you can make them annihilate. And that's a tremendous amount of energy. But a tremendous amount of energy is exactly